In example 115, we're working again with a future value annuity and something that we call a sinking fund. In general, these future value annuities model a situation where we're building an account up from zero to some particular amount over time. And in this situation, we've got a company that knows that it needs to end up with $800,000 in 5 years. And to have this money available, it's going to make some equal payments into an account that pays 6.6% interest compounded monthly. So let's write down things that we know. In this situation, we know the interest rate, 0.066. It's compounded monthly, so M is 12. They've got to have this money in 5 years. T is 5. And the amount that they need to end up with is $800,000. That's a future value. What we need to figure out is how much should each of the payments be. So there's our unknown. Now the formula that we have to use for these types of situations looks like this. And it's sort of set up to spit out a future value. Now, I think what I'll do, I think it might be just slightly faster, is I'm going to rearrange this formula so it's ready to spit out an amount for the payment. And in this equation, basically, we could think of this future value as given by multiplying this payment amount by this big-looking fraction. So to solve for payment, all I'm going to do is multiply both sides by the reciprocal of that fraction. And so now we've got this formula that we can use. PMT, the payment, is equal to the future value times R over M in the numerator, and then 1 plus R over M to the MT minus 1 in the denominator. And we're ready to plug in the values that we've been given. So our future value is 800,000. R over M. And we can simplify these expressions a little bit. So let's figure out what R over M is equal to. 0.066 divide by 12 gives us 0.0055. So there's the numerator of our fraction. And that comes up again, of course, in our parentheses right here. So the total in the parentheses is 1.0055. This is being raised to the power 12 times 5 is 60. And now we've got something ready to plug into our calculator. We have payments of $11,290.42. And these payments are monthly payments. We know they're monthly payments because they agree with the compounding periods, right? So since M is 12, since this is compounded monthly, then these are monthly payments. In part B of this problem, we want to figure out how much interest is earned during the last year. And so not the total amount of interest overall, but just during this last year. And the approach that we can take for this is to just figure out the total change in the account amount from year 4 to year 5, and then subtract out how much of that was from the payments. So that's our sort of plan. We're going to find the change in the account from year 4 to year 5, and then subtract out the amount made in payments for that last year. So to figure out the change in the account from year 4 to year 5, let's find the future value after 4 years. So we're going to use our formula. Future value is equal to payment times 1 plus r over m to the mt minus 1 over r over m. And we know from what we've already done, the values for r over m and 1 plus r over m. The payments we solved for in part A, $11,290.42. And in our numerator, we've got 1.0055. And now t is equal to 4, so this will be 12 times 4. And then subtract 1 over 0.0055. It's going to simplify the exponent. And now we can use our calculators to calculate this future value after 4 years. Putting parentheses around that numerator. Then dividing by 0.0055. We get $618,277.04. So this is the future value after 4 years. I think I'll denote it with an FE subscript 4 just to avoid any confusion. Now at year 5, we know that at the end of this whole process, the future value is equal to $800,000. That's how we found the required payments. Is because we wanted to end up with $800,000 at the end of 5 years. So now that we have these figures, we can find the total change in the account during the last year. Just do a little subtraction. And we have $181,722.96. Now this is the total change in the account during this last year, so it includes those last payments, those last 12 payments, one each month during the last year. So we need to subtract those off. And so we take our overall change in the account during this last year minus 12 times the amount of each payment, 11,290.42 cents. And this will give us the amount of interest during the last year. We have $46,237.92. This is the amount of interest just in the last year.